Go. We've learned how to add, subtract, and multiply. We're going to learn how to divide polynomials. Part of this is going to look like review for you, but it might seem slightly new. As I divide these polynomials, and by the way, this is not really our goal. Our goal is to discover all the solutions to polynomial equations and graphs. In order to do that, we have to reteach you how to do long division. And so we'll see what you remember, and then we'll show you a shorter way of going about it. But this is what you should be able to do, is take x plus 2 and divide it into 3x plus 6. So as we divide these, the way I go about this is I say, what do I multiply x by to get 3x? 3, okay? And that goes actually above the 6 because it's a constant. Then I multiply the 3 back through, and I get 3x plus 6. And I subtract those, and I get 0. So 0 is my remainder. Everybody good with that? 3 is the answer. Now, there's other ways of going about this. If you had 3x plus 6 over x plus 2, notice you could just factor out the 3. You get x plus 2 over x plus 2, right? And they just cancel, and you get 3. That's the same thing. We did the same thing. Now you're like, well, why don't we just do that every time? Because sometimes you can't see that it factors. Would everybody agree you don't know how to factor x cubed minus 6x plus 4? And if you do know how to factor it, then good for you. I don't. So you're doing pretty well. So let's divide and see if we can get something to factor out and cancel. So I write x minus 2 goes into, and what do I write underneath the division symbol? X cubed. You may know what goes next. 0x squared. Okay, so Maya, where do you work?
I work at Algebra and Tutoring.
Awesome. What was your last paycheck? All right, $230. So Maya gets paid $230. Okay, suppose we say, you know what? You know what? Instead of giving you the $230, we're just going to give you the $23. How's that? Is that my phone? Sorry about that. Turn that off. So, Maya, how would you feel if we gave you $23 instead of the $230?
Not very good.
You'd be pretty upset, right? Because this placeholder matters. Same way the 0 matters. So let's go to work here. X times what is x cubed? So therefore, we place the x squared above the x squared. We multiply it back through. X squared times x. X cubed minus 2x squared. And I subtract those. Notice how the x cubes go away. We determined that by this first result, by deciding what you multiply x by to get x cubed, that ensured that those will cancel. So I have 0 minus negative 2. Positive 2 x squared. Because it's a binomial, 2 parts to it, we will bring down this minus 6x. Do I have a question about how we got the 2? So it's a 0x squared, and it's minus negative 2x squared. So I'm taking that minus that, so we add the opposite. Nope, not the plus 4, because it's a binomial, because it has 2 parts. We just want 2 parts there. Okay, so I don't bring down the 4 yet. I start over. What do you multiply x by to get 2x squared? 2x. So I put the 2x up top, right above the other x's. You multiply back through, and I get 2x squared. Then what? Minus 4x. I'm going to subtract those. Good. Negative 6x minus a negative 4x is a negative 2x. Because it's a binomial, I drop down the second part, this plus 4. Just two things because it's a binomial. So what do you multiply x by to get negative 2x? Negative 2. I distribute that back through. Negative 2 times x is negative 2x. And negative 2 times negative 2 is positive 4. I subtract, what do we get? 0. So the remainder is 0. Now, we go through all that work. Hannah's taking the test, and she's like, boy, I'd really like a way to check my answer. Here's a great way that Hannah can check her answer rather quickly. Trust me, you will use this. It's super quick. It's called the remainder theorem. What would you plug in to make 0 for this binomial right here? If you take the solution of that binomial and just plug it in here, that will tell you the remainder. Watch. What's 2 cubed? 8 minus 12 plus, what is 8 minus 12 plus 4? It is 0, which is my remainder. So you can check your result every time. We're going to do one more of these long division problems, and then we're going to show you a better way. Okay, I'm going to start by making an informed guess about what it should all look like. I'm going to take the solution of this, which is 1, and I'm going to plug it in. What is 1 to the 4th? We're going to skip this one. 1 minus 4 plus 2. What's 1 minus 4 plus 2? Negative 1. So I should come up with a remainder of negative 1 if I've done it correctly. Is everybody okay with that? So let's go about it. I put the x minus 1 on the outside. What goes underneath? 0x cubed. 0x plus 2. Good. So we got a couple of placeholders in there. What do I multiply x by to get x to the 4th? X to the 3rd. Multiply that back through, and I get x to the 4th minus x cubed. I subtract 0x cubed minus negative x cubed, positive x cubed. What do I do then? Drop down the negative 4x squared because I have a binomial. I need a binomial. Now, obviously, I think hopefully you guys see that we could change this up. Instead of having a binomial up front, we could use a trinomial, right? And that would change the way it goes. We don't really need to do that. It doesn't happen very often in math, and if it does, you'll be able to figure it out. We want to just solidify this. Okay, what do you multiply x by to get x cubed? X squared. So I get x cubed minus x squared, and I will subtract. Negative 3x squared plus 0x. I get a positive 3x there. When I subtract it, what do you come up with? A negative 3x. What do I do? Drop down the plus 2. What do you multiply x minus 1 by, or what do you multiply x by to get negative 3x? Negative 3. You get a negative 3x plus 3. I subtract and you get negative 1 is the remainder. Now, I want you to show how we write a remainder of negative 1. Because when you were in grade school and you took 14 divided by 3, I don't think that your teacher always allowed you to do this. They didn't always allow you to say, well, that's 4 with a remainder of 2. That was not always accepted, was it? there came a time where your teacher expected you to do this. It's 4 2/3. Agreed? So if you look, the remainder's on top and the quotient is on the bottom, right? So the way you write this is a minus 1 over x minus 1. The remainder over the quotient. The remainder over the quotient. That's your result. Plus 1 over x minus 1, yes. You good with that? Okay, so that's long division. So I used to give people an assignment on long division. Can we all say that we understand long division well enough?
Yes.
And that we want the better way. Okay, so let's show a quicker way of going about this. Agreed? Here we go. We have this beautiful thing called synthetic division. And synthetic division operates rather quickly. Here's how I organize my work for synthetic division. Okay, I look at what number I plug in to make 0, which is, and I put that here, and I use a half box. I then place the coefficients across the top. 1, -4, 2, and 1. I give myself space, and then I draw a line, and I use another half box there with an R to tell me the remainder. That's how I organize my work. Does anybody remember how I start the process of the synthetic division? I actually drop the 1 straight down here. And then I multiply. And I get 1. Instead of subtracting, I add. It's nicer to add than it is to subtract, isn't it? It's part of what makes this great. -4 plus 1 is? And then I multiply. 1 times -3. -3, I add to get -1. I multiply, and I add 0. Remainder is 0. Now, here's what these mean. This is my constant. This is my coefficient for x. This is my coefficient for x squared. So the result is positive x squared minus 3x minus 1. That is dividing those two. And I would suggest that that's faster than the other option. I have had one class before that said I would rather use long division than synthetic. And since it is America, we allow people to make their choices. But we also allow them to live with the consequences. So if you want to live in just, the world of long division, then you can suffer, okay? But I think, like, if it's kind of election day, isn't it? If we were to have an election between long division and synthetic division, synthetic's winning out, isn't it? I think so. People can still choose the other side, but synthetic's winning out. All right, we do 2 more. We're getting rid of this one. What number do we put in the top? -2, half box. What goes across the top? Yep, got to remember that that 0, that placeholder is important. We want Maya to get $230, not $23. How do I start? Drop the 4. Then what? I get -8. 0, 0, 0, 0, 4. Sweet. I mean, if it's to the 4th power, that would take a while, wouldn't it? It'd take probably 5 minutes to do that whole problem, and now we just did it in about 20 seconds. So this is the constant. This is x. This is x squared, and this is x cubed. So we get 4x cubed. We have a plus 4. And how's it going to end? Good. Better option, right? Try letter D on your own. Notice that the negative x cubed is sitting at the end there. Go ahead, try D.
What? We do.
Very good. Going once, twice, 3 times. Okay, there you got it. So we all know how to do synthetic division now. This is just the skill that you had to have in order to do it is really, really, really cool. There's a few moments in my life where I decided, without a doubt, I will be a math major. Didn't know for sure what I was going to do with it, but I could think distinctly of 2 moments where I said, I'm hooked. Okay? This was one of them. And I know as you look at it, you say, that looks like complete gibberish, right? We're all different, and for me, when I saw this, I thought it was one of the most beautiful things I saw in my life. And so, understanding that you might be thinking I'm kind of geeky at this point, can you please engage to try to see what does he find that's so beautiful about that? Can you? Try to find what's interesting? Okay, humor me for a second. Yeah, here's what it's saying. It says, let there be a polynomial of this form. And this garbage right here, all it really means is that the polynomial looks something like this. I have, say, polynomial of x is equal to, you don't have to write this down, but you can if you want. Say, like 2x to the 4th minus 5x cubed plus 6x squared minus 3x plus 3, we'll say. Okay? So it's a polynomial of that form. And I've told you before that if it has a 4th degree, then how many solutions should it have? It should have 4, okay? So the question is, like, what are those solutions? And there's a lot of numbers on this world to choose from, right? Like, there's a heck of a lot of numbers. Like, from negative infinity to infinity, that's a lot of numbers, right? Here's what the rational roots theorem says. It says, suppose you have a polynomial like that, where a sub n, or the lead coefficient, has factors of q. Okay? So we call this 2 here up front. We call that a q. Okay? Q. What are factors of 2? 1 and 2. Agreed? Okay, that was easy, right? And then it says an a sub 0, or the constant that sits at the end, that has factors of what we'll call p. And so p is going to be factors of that last number. What are factors of 3? 1 and 3. Then it just so happens that out of all the numbers between negative infinity and positive infinity that are rational, we can isolate the number ones that could actually be solutions. It's these divided by these. For example, if you take 1 divided by 1, you get 1. If you take 3 divided by 1, you get 3. Let's move on. If you take 1 divided by 2, you get 1/2. And if you take 3 divided by 2, you get 3/2. So it turns out between an infinite set of numbers, there's only 8 of them that could possibly be solutions. Like, we narrowed it down to that. That's pretty good. And it allows us to do some absolutely remarkable things. If you flip it over to the next side. We want to be able to do x cubed minus 7x minus 6. Now, you look at that. To your knowledge, does that factor? No. And the beautiful thing is, it does factor. We just can't see it. We're limited. I look at it, and I can't see how it factors either. But we're going to see how. And the first thing we're going to do is this. We're going to identify the degree of the polynomial. It's degree what? 3. That means it should have 3 factors. It should have 3 solutions. We list the p's. The p's are factors of the back. What are factors of that back number? And then q's are factors of that front coefficient. 1. So out of all the choices that could be possible solutions, I've narrowed it down to whatever these divided by this is. And we always list plus or minus. So plus or minus 1, plus or minus 2, plus or minus 3, and plus or minus 6. Like, again, we've narrowed it down to 8. That's a pretty good deal. It's pretty slick. And now at this point, we really don't have a mathematical option other than to just guess. So we just got to plug one of these in and see if it works, see if it gives us 0. Anybody want to take a guess? You want to try 2? Why not just start with 1? Like plugging in 1, I mean, if you're not going to get a calculator for this test, plugging in 1's like kind of a nice option, right? Yeah, so what's 1 to the third? 1. Minus 7?
Yeah.
That gives negative 6, right? Then we minus 6 again. Does that equal 0? No, 1 did not work, so we move along. I like to try negative 1 next. So I'm going to plug in negative 1. What is negative 1 cubed? Negative 1. Is it going to be plus 7 or minus 7? Plus 7, because negative 7 times negative 1 is positive 7, and then minus 6, does that give me 0? It does. So negative 1 works, which means that x plus 1 must be a factor. If negative 1 works, then x plus 1 is a factor. So I'm going to divide this thing by x plus 1. So I put a negative 1 out front. What numbers go across the top? 1, 0. Now, we already learned how to do this. Like, we're really good at that, right? Like, we could have a whole test of those problems. We'd be like, yeah, I'll ace that thing. So we drop the 1, multiply, we get add, multiply, add, multiply, add. If you don't get 0, you did something wrong, because it should divide evenly. I mean, we came up with 0 when we did it here, so it should come out to be 0. So it turns out that we get x squared minus x minus 6. So this thing does factor. It factors to that. Notice you didn't see it factor, but it does. Does x squared minus x minus 6 factor?
Yeah.
To what?
Minus 3 minus 3.
Huh. Interesting.
Oh, so the other solution.
So what are my solutions?
Negative 1, 3, and negative 2.
Look at that. And is it the case that 3, negative 1, negative 2 are my choices? Yeah. X plus 1. When we plug negative 1 in, negative 1 worked. That means x plus 1 is a factor. Yep. Kind of slick, isn't it? I mean, it almost seems a little bit like cheating because you're kind of guessing, but in mathematics, we're doing what we call educated guessing, which isn't a bad thing. We do one more today, and then we continue on with tomorrow. So let's try to lean in, and you guys help me out with this. Degree 3. What are my P's? Yeah, 1, 2, and 4. They're factors of that. Those are my P's. And then Q's, just 1. So that's where we start. So what are my choices? So I've narrowed it all the way down to 6. Again, that's a good deal. So what do you want to start by plugging in? If we plug in 1, what's 1 cubed? Is it going to be plus 3 or minus 3? Plus 3 and then minus 4. Does that make 0? Yeah. It does. 1 worked. So if 1 works, then what's the factor? X minus 1 is the factor. So I'm going to divide that in. I put a 1 up in the corner, and then what goes on from there? Sir, if negative 1 worked, then x plus 1 is the factor. If 1 works, then x minus 1 is the factor. It's whatever the solution is. I drop the 1, and I multiply. I get 1. I add, and I get 4. Multiply, I get 4. Add, I get 4. Multiply, I get 4. Add, and I get 0. You must get 0. If you don't, you did something wrong. Turns out I've got x squared plus 4x plus 4 times that x minus 1. That's what this thing factors to. Does x squared plus 4x plus 4 factor? X plus 2 times x plus 2, or x plus 2 squared times x minus 1. X is equal to what?
-2 twice.
Please list the -2 twice to show that it's a double root. The fact that it's a double root, does that impact the graph? Could we graph it if we wanted to?
Yeah.
Yeah, super easy, right? Just to bring back what we learned the other day, it crosses through -2 and it crosses through +1. And it has a double root at -2. So I should see that kind of a graph from you. So remember, at the beginning of this unit, I told you that what's great about this is at the very end, I could give you one problem that tied everything together. Notice how I gave you a problem right now that actually tied our first two lessons together, didn't I? Yep. And you could continue to do that each and every one, which kind of ensures understanding the whole way. You can start on your homework, though you do not need to finish it. We're going to go through a couple examples tomorrow, and then you're going to have some time to work on your own. Okay?
We didn't draw the graphs. I didn't know if you wanted to on that one. Well, we can do that.
Oh, don't worry about that. But we'll look at that tomorrow. But otherwise, you got those other pieces done? Thank you. We'll see you tomorrow.